Hello everyone. So we're back for day 9 of coding every day here. So today is January 24th. It is a Friday today at 5:58 p.m. So today we're going to be looking at this problem here, this LeetCode problem, and reminder I'm trying to complete this roadmap here. So this is a linked list problem, medium linked list problem. I haven't looked at it yet. I'm not too great with linked lists, but let's see how it goes. Okay. You are given the head of a linked list of length n. Unlike a singly linked list, each node contains an additional pointer random, which may point to any node in the list or null. Create a deep copy of the list. The deep copy should consist of exactly n new nodes, each including the original value, a next pointer to the new node corresponding to the next pointer in the original node, a random pointer corresponding to the random pointer of the original node. None of the pointers in the new list should point to nodes in the original list. Okay, so we're basically creating a new linked list, which is a deep copy of the given list. And then return the head of the copy. Okay, in the example, the linked list is represented as a list of n nodes. Each node is represented as val random index. Where random index is the index of the node 0 index. Okay, so 3 is random points to null. 7 points to 0, 1, 2, 3. So here, yep, the red. 4 goes back to 0 and 5 goes to 1. All right. And then we output the same thing. Okay, and time space is oven and oven space. So we can use oven space, which makes me think we probably want. Okay, let me just traverse through the node here. So if I say current equals head, while current does not, or I guess just while current equals current.next. Okay, so this would give us so 3745. Okay, so we should create a new linked list. I'll call it L2. Okay, so I don't really even understand the problem exactly. I understand the problem. Okay, I understand the problem. I just don't know like how to get started or like what the tricks are yet. So we go. So obviously we can recreate. So if we just recreate the list, so if we say L2, so I'm guessing I have to create a node. And then I'll give it head.value, none, none. Okay, yeah, so it takes in a node and a node. So this is the head of, I'll just say list 2, which is the copied list. So then I could say C equals L2. This gives us just 3. So I'm thinking first of just creating a deep copy of this before we worry about the random, and I'm guessing the random is like where the tricks and stuff are. So if we say while C, we say, okay, so C equals head. All right, C2 equals L2. All right, so C1 equals C1.next, and we want to say C2.next equals a new node, and then C2. So we're going to kind of create node as we go, which is going to be equal to C1. Oh, I'm thinking if maybe it should be like a previous pointer almost. Because if we say C1.val, yeah, let's try previous. I think that's because we need to point to where it goes. So previous one equals none. So we'll say previous one equals current one, and then current one equals current one dot next. Okay, so currents 2 we want to set equal to the previous value. Well, this will start as none. Okay, so we'll say, and then C, and then we'll just say none random. And then at the end, we'll say C2. We also want to increment C2 equals C2.next. And then C2.next equals we have to do it once more. P1. So C2 becomes next here. Yeah, so I kind of almost want it to be one behind. Okay, so I think I'm getting a little lost. My idea is, what number is it? 3, 7, 4, 5. So my idea is and this goes to none. So currents will move, and then our goal is we want to create a copy of this. But to create a copy of this, we need to know its next value as well. So to create a copy of this node, we need to know its value and its next position. But we don't know. Oh, actually, we could just say, C2.next equals C1.next. Like that. Oh no, but we have to create a node. But we could say, okay. So we say C2 equals a node with the same value with the same next. But that will point to another list. Or another node that already exists. So we don't want to point to this node. We want to point to like a copy of this node, so we'd have to create like another node. So I think what I have with the previous and current actually makes sense. Okay, so now let's assume in the main list we have previous and current. So previous and currents, like that. And then for 2, so current 2, we say equals a new node with previous dot value. And then for next, it'll be a new node that we created, which will be of the same same this. So node of which has current dot value. And then how do we get that one's next? I guess we don't. But we can set it. So maybe we can just say none for now. So we say C2 equals a node with none and none. And then okay, I have another idea. So if we have C here, we do this code. And then once C goes up, so like C equals C dot next, then we say C2, which still refers to this node, C2 dot next. So that's still this. So we're setting the next. So we have C2 here still. So C2 dot next equals a new node with the value 7. So C dot val. And then this would be C dot val here. C dot val. And then with C dot val. And then we do none none again. And then we say C2 equals C2 dot next. So this might only have to happen once. So if we look at just this loop right here. So let's assume that C2 is initialized already. So we have a node and its value is, let's say 3. So let me just redraw it here. So it's 3, 7, 4, 5. I won't do that. So assuming the value is initialized already. Okay, so we say C2.next points to a new node with the next value, and then it has none. So C2 is here. And then we move C2 over here. And then we say C2.next points to a new node So this sort of loop makes sense to me. So I'll just try that, I guess. So we'll see where this gets us. So we want to initialize the head of C2, which is what we do here. And I'll just say C2. Did I delete something important? Yeah. So we'll say C2 equals L2 head out here. We don't need previous. We don't need that. C1 equals head. Okay. So we'll say C1 equals C1.next first. I'll just call it C. And then C2.next is going to be equal to a new node with the value of whatever C is at. And then none and none. And then C2 itself is going to be equal to C2.next. And then at the end, whatever C2 is, we're going to point it to none. It's next. Okay, let's see what this gives us. Unexpected indent. Oh. Is it possible we can put this at the end here? Well, we do know that current has to be... I think I could say while current.next. Output, I return nothing. So I want to return L2 head. Three, 7, 4, 5. Sweet. That looks right. 3, 7, 4, 5. So the only thing now is that we want to set when we say c.val, we want to say c2.random equals okay, so there's two attributes here. So I think this looks good so far. We got something's working, because we've made a copy of just this, and now we can start to think about the random pointers, which I think is just another attribute. I don't think it's actually important where it's pointing to. So we want to copy. So if we look at our methodology, it starts with just this, and then we say, so we initialize that. I'm just going to erase this. Okay, so we initialize this, and then C, so here's C2. C equals C.next. And then we say that the next pointer of this, okay, let's say like temp, maybe. So temp is the node that we're creating. And we could say, so we want C2 to point to that, and we want okay. So, okay, I get it. So the random pointer has to point to something that already exists. Okay. So, I mean, maybe we could do another pass through and just store the random values in, because we're supposed to use O of n memory. So maybe we could store So we create a new node and point next to it. And then we create a new node and put this next. And then we create a new node and put this next. So we could say, we could keep track of an index possibly. And then I'm thinking maybe we could do a list. Well, I mean, we could just store everything in like an array, but I feel like that's kind of cheating. Also, we could have a dictionary that's oh, maybe that's how you're supposed to do it. That maybe maps the index to its, maybe like index to node, where we have 0 goes to like a node object. Well, so at that point, we should just do a list. Or just call it like nodes. And then we would say nodes.append C2. So now we would have a list of nodes. And then if we iterate through it, we could say this one equals nodes of whatever. Okay, let me say for node and nodes print. Let me try that. 374. Okay. So this takes care of all their nexts. But for the random, like for instance, this one, or let's look at this one. This one has to point to something 2 steps in the future. So you could point to something that's n steps in the future. And to do that, you need O of n memory. So this only does 1 step in the future, but it's not really capable of doing 2 steps in the future, because I would have to say like that or whatever. So random points to random index. Okay, so can I just say for node and nodes, node dot random equals nodes of. So we don't want this, because this will point to that'll point to a node that already exists, and we want to copy it. Okay, so random index. Do we say that? So node.random, we're setting it. I feel like that looks kind of right. None type. If node.random. So it's null. Okay, so let's print the value and the random that it goes to. So this will be not human readable, right? Oh no, it's all none. Nodes of. Okay, let's print this. Actually, I want to print node.random. Is that an integer or is it a node? It's a pointer, right? Oh, it's because I'm setting them all to none. So instead, what should I send? I guess I could just set them to whatever. Let me see up here. Print c.random. Is it an integer? No. So why does it say each node is represented as a value random index? So do I need to map the values to their index? Because I'm not given the index. Well, it says that I am. So it prints 5. So this goes to 5, this goes to 3, and this goes to 7. This goes to 7. Okay, so do I put it in the dictionary? Is that what I'm supposed to do? So does it take the value and map its index? I want to get its index, right? Yeah, so I guess I could put this. And then are all of them unique or? No, I don't think so. Okay, I'll just go with this for now. So be a dictionary. And then what we want to say is so we could say val to index of c.val equals I. So 70. That's not correct. Okay. I think maybe I'm gonna go back to the whiteboard for a bit. Okay, so we have 3, 7, 4, 5. Okay, so I'm allowed to use O of n space. So can I just simply store all of them in a list and then create a copy of that list basically? So it'd be like 3 points to 7 and then points to null. So it'd be like the value, its next pointer. So if it's a node itself, I'll put an n, and if it's a value, I won't. So, oh no, not this again. Okay. All right. So the value 3, the node 7, and the node, or it would just be null. Okay. And then the index would be the position. And now this is 7 value, node 4, and the randomness points to 5, node 5. And then we have 4 points to node 5 and randomly goes to 3, node 3. And this is 5, which goes to null. And then randomly points to 7n. So could I just say for node in nodes, so we'll create a node. So we could say like n equals node with node of 0, node. Okay, so we want it to point to a new one. So would we say node? No. So I think I had the right idea with what I've done, but the problem is now just doing the random pointer. So what do we need? So this is good. So let's keep this. So let me think. What do I need? Okay, so this gets us everything with none, right? Okay. So for instance, when we get to here, So when we see that c dot random so we initialize with 3. That's it. Has none for everything else. So this will be next and random. So then we create a new node and set its value to 7. And then we point next. Well, maybe what we could do is so we create the next node and point next to it. Can we also create the random node? My only problem is I think it doesn't have to be unique. Because if we make the value of the node the key, like if we knew where what index that was at, so let's say this one R points to null. Okay, so we create 7. Now we create 7's next, which is a value of 4. We point it. And then 7's random, which is a value of 5. So we created both of those. So then we go to 4. So 4's next value already exists. So we point next to there. And then 4's random value already exists. And it is what? 3. So then we point this to 3. So is it like you have to keep track of everything that you've visited? Or like that you've seen before? And check if that value already exists, then connect a value to it. Or like connect it. And if it doesn't exist, then create a new node with an empty next and empty. Okay, so I'm thinking maybe if we have a set or a dictionary, say created, something like that. Maybe we could have a dictionary, which is its value and its node itself. So we've created like this. So we've created that. And then maybe we could say like just like a stack or something which keeps track of the nodes that we've that have not been created. Okay, so yeah, and then by the time we get to c.next, we're probably good. Okay, so we'll say, let's just say while c. So for our first c, so for the head, well, for everything, we'll check if c.next.value is in created. If it's in created, then we say c.next equals created of c.next.val. And same with random. So if c.random.val is in created, then we'll say c. This assumes that all of them are unique, which if it's not, it doesn't say it. So we'll see. So c.random equals created of c.random.val. So this gives us the node itself. Okay. If next is not uncreated, then we will create a new node. Well, I guess we don't have to have this stack thing because we're going to explore all of them eventually. Because we'll always make c equals c.next. So I don't think we need this. Okay, c.next equals node, a new node with c.next.value, none and none. So that means we would need this. Okay, and then we also want to add it to created. So created of c.next.val equals c.next. Okay, and then same here. So c.random is going to be a new node if, okay. And then created of c.random.val equals c.random. So we don't need c2 anymore. So let's see what errors that gives us. Random. So if it's in created, maybe we should say null goes to null, or like, well, it has no attribute. I guess I could say if c.random. So if it's null, then we say c.random equals none. We basically don't want to do anything if random is null. I don't think we need this then. Okay, so if we look at this code, c.next.value is not in created. So we said c.next to a new node. And then we say created equal, so created of 7. So let's trace it here. Let me see if it's iterating through all of them, first of all. No, it's not. Oh, is it because we're setting c.next? Okay, so that gives us all of that. So if c.next, all right, so let's look. So 3 point signal. If c.next.val, so it is in created. Wait, no, it's not. c.next.val is 7, which is not in created. So we say, and we already created this one, right? Yeah. Oh. Why did that not give me an error? Okay, if c.next.val, so is 7 in created? No. So we set c.next, so this skips. c.next equals a new node, equals a new node of value 7, and then none and none. Okay. If not, c random equals none. So this just points to none. That's good. Okay, and then c equals temp, which is over here. So now we print 7. If c.next.val, so if 4 is in created. Oh, did I add? Yeah, and then I also said created of 7 equals this node. Okay. So 4 is not in it, so we do the same thing. So 4. So we do the same thing. And then created. So now created has 7 to node 7 and 4 to node 4. Now for random, so random points to, so C is still 7. So it's not in there. So we create node 5. created. Okay, and then we have 5 node 5. Okay, and then C goes to 4. So we print 4. If C.next, so 5, so it should be in created. So um, five, right? Perfect. So 5 is in created. So C.next equals 5. So we point this to 5. And C.random. So where does random go to 3? So it's in created. So this should go to 3. So now this should get me 3. Perfect. I think I could just say while C and then do the same thing here. So if not C.next, then C.next. So if it points to null, then just set it to null. And I think that'll give us the extra loop that we need. 5. So 5 dot next is fine, but random, it should be, so if c.val is 5, print c.val, c.next, c.random. Actually, let's do c.random. Those are going to give me nodes. So print, it goes to 7. So C, and then also let me, whenever we add something, let me say prints adding like that. So do I need an elif there? Is that what was wrong? Okay, yeah, that's what was wrong. So then it should point. So, okay, so if I say C equals L2 head, while C equals C dot next, let's say print C dot val, C dot next dot val. Can I say if C? I don't know. I don't think I can do that. I don't think I can do that. Yeah. All right, just take my time. C dot val. If C dot next, then we will print c dot next dot val. I think I was modifying the original. Okay, I think I'm on the right track. I just maybe wasn't creating a copy. So when we do this, we're creating a new node. But we're saying c dot next. So we really want like c2. So we don't need that. We don't need this. So we do need that. So this iterates c. And then we should say c2 dot next equals none. C2 dot next. C2 dot next. C2 dot random. I think whenever we're setting something, okay. All right, I think we got the logic. Just a couple things. All right. So we want C to basically loop through, and everything else we want. So that's what I have, and then I have C equals temp. And when we're checking something, so if C dot next equals none, I guess I'll just say that. then so this looks bad, but it just means skip those basically. I mean, could I say if c2.next like that? Or if cu, and then if, because otherwise we just don't want to change it. Okay, let's trace it with c1 and c2, and then I think we'll get it. So created has 3 and node 3, and that's, so these values, what we're adding has to be C2s. We have to be adding C2s. Okay, I'm back. Sorry, there was a car alarm going off. So yeah, obviously we want created. Does that work? Oh shoot. Yeah, I don't really know what this means exactly. So it looks like is L2 head like none or something? Just doesn't. Okay, so 3, 5. So that's incorrect, right? It should be swapped. Did I swap them? So the values should not matter. Okay, so we added 7, we added 4, and we added 5. Next val in created. Okay, so then okay, so we added it to created for 5. C.next.val. 3745. Okay, so we have currents and current 2. Okay. So every time it moves up, they both move up by 1. Alright, so then we have temp. Okay, so if that's if it's non-null, which it is, if c.next.value, so if 7 is in created, wait, what? Okay, so if it's in created, then, so it's not, it's just not, so we skip it. And then let me just make sure. So this print statement should not execute, okay, for any of them. Okay, so it's not in created, so what we do is c.next, so c2 is what, c1? No, c2 is its own list. It's a new list with just 3. So we say c2.next equals a new node with the value and none, none. Okay. So it's next equals a new node with none, none. And now created, we add 7. And is it possible that, no, we add L2 head. Okay. Node 3. Okay, so then we add 7 and node 7. Alright, so we're here. Now c.random is null, so we skip it. And now c2, oh, c2 is going to here. But we really want it to go to c2 equals c2.next. And do we ever update c2.next? Well, yeah, we do. But it could be to a node that we created. So I think that's okay. No. Oh, it's because I'm printing. What are these errors that I'm getting? Runtime error? Run.sh 11 killed. Did I delete something by accident? If I run it, does it still work? Yeah. So it seems to be working. Is it like because I have stuff? This is weird. I don't really know what to do with that. I've never seen that before. I doubt this will work, but I'm just gonna refresh the page. I've never seen that before. Line 1. Okay, I'll be right back. I'm gonna see what this error means. All right, guys, I'm back. So I tried running it in LeetCode and it said I got like a time limit exceeded. Um, I'm not sure if it has to do with something with like duplicates or if I have an infinite loop or something. I don't think I do because I'm always saying here c equals c dot next. Um, I'm never even reassigning c dot next to anything, so I'm really not sure why that's happening. And it works for these cases, and even if I delete all the print statements, I think honestly I can just say c equals c dot next. So when I submit it still doesn't work. I get this kill thing, which I don't know what that means. So yeah, I'm not really sure. I don't know what it means. I'm guessing I have an infinite loop or something. It's really confusing. So I looked at the hints because maybe I was doing something wrong. So it says you could use a hash map, which I used, but this thinks, or I mean, the hint says you should map nodes to the copies. So you do like a 2-pass solution. So the first pass, I guess I like overthought this a little bit, but the first pass you just create like a copy of every node, and in the second pass you just assign the pointers and stuff. So I mean I could try doing that quickly. So to copy, so basically just go through first list and create a copy of each node. So say while c equals c dot next. So we'll just leave the pointers blank, and then we'll say to copy of c equals temp. So c like that. And then we could say for entry in to copy, print entry dot, is it like items? Okay. So I could print a copy, which maps nodes to other nodes. So if I say for item, it's a copy. Maybe I could say to copy dot items. So item gives you a list of, so items gives you a list of tuples. So item 1 would be the original. So I mean, we could say like node next, node random equals item of 0 dot next. Oh, but we want it to point to this node. Want it to point to this node. Oh, I see. So for node next, so we would say item of 1. I guess let's say original node and copy node. Okay, so we want so copy node dot next should be equal to node dot next, but the copy of that one. So two like that, and then copy node dot random should be set to node dot random, but we want the copy of that one. For the head of the linked list, we should return to copy of head. Oh, if it's none. So if node dot next is not none, and if node dot random is not none, otherwise we could just leave it at none. Wrong answer. Okay. Okay, there we go. So I don't know what was wrong with my first solution, but so I had to look at the hints here. So I think I had just copying it, I think I had the right idea, but when you add the random element, it gets a little trickier. So yeah, so this one was kind of weird. I'm glad I got to solve it at least instead of just giving up. I think also too, after last week, I kind of came into it with more confidence and maybe arrogance, because it took me like 15 minutes for the other medium problem. So I thought like I could just kind of do it. So I should have probably spent more time whiteboarding. But yeah, the tricky part was just creating a deep copy. So I should have focused more on that rather than like the random stuff. Yeah, so there we go. So let's submit it on LeetCode. So I still was able to do it. I just needed the hint, which suggests that my problem solving maybe skills are for linked lists could use some work, but that's why I'm practicing. But I was able to code it pretty quickly once I knew what to do. But anyway, that's for day 9. That was a long and painful one, but I'll be back tomorrow. See ya.